What I'm going to do is I'm going to start with the examples that I wanted you to do on practice sheet 4. I hope you all did try to do those. Also, I hope you did the work on Delta Math. There will be more work. And after I finish going over these examples, I'm going to talk about our next quiz and how it's going to run and what we're going to be doing. Okay, I gave you examples 16, 17, 18, 20 through 23, and 26 through 29 on this practice sheet 4. I'm going to go over all those examples so that we have a complete review of what we did last week. And then we'll continue finishing up with factoring of trinomials, and then we'll go on from factoring into solving what's called quadratic equations. That's what we're going to be doing today. So first, I gave you question number 16, and it said factor the trinomial x squared minus 5x plus 6. And if you recall what we said when we are factoring any kind of factoring, whenever we're doing any type of factoring, what we're doing is we're first looking for what's called a common factor. But there isn't any common factor, there isn't any number or letter that goes into all three terms. So then when we have a trinomial, we try and break it up into our two binomials. Now, you can't always do it. Not every trinomial is factorable, but we do try. What we do is we look at our first term, which in this case is x squared. We break that up into x and x. And then we look at our last term. First, we look at the sign. The sign of the last term is positive. Remember, that means both signs, we multiplied a number to get a positive answer. So therefore, both signs have to be the same. They either could be both positive or they could both be negative. I look at the middle, since that one is negative, it must mean that both of them are negative. In other words, it's going to be a negative in each parenthesis. We then look at the number is 6, and think of numbers that multiply to 6. So 1 and 6, and 2 and 3 are the two combinations that we come up with. And since we're looking for two numbers that multiply to 6, but since this is a plus, they have to add to 5, it must be the 2 and the 3. So we put a 2 in one parenthesis and a 3 in the other parentheses. It doesn't matter if you would have written x minus 3 first and x minus 2 second. That is the way we would factor this trinomial. Okay, then I gave you number 17. Number 17 is m squared minus 4m minus 45. And we want to factor this trinomial as well. Again, there is no common factor. So we're going to look to see if we can put it into two binomials. Okay, the m squared again, we put as m and m. And now I look at my last term, it's negative. Remember, when the last term is negative, it means you multiplied a positive number times a negative number. So one of your numbers, one of your signs in your parentheses is going to be a plus, and the other one is going to be a minus. And now you're looking for numbers that multiply to 45, but since this is a minus, they're going to subtract a 4. Now 45 and it could be 45 and 1. It could be 15 and 3. It could be 9 and 5. I think those are the combinations that I could think of. We want those combination that subtract to 4, obviously that's the 9 and the 5. Now we have the different signs, so I have to decide where to put the 9 and where to put the 5. Since the middle term is negative, it must mean the negative goes with the larger number. The larger number is 9, the 9 has to go with a minus. That means the 5 goes with a plus. Again, you could have written it m minus 9 and m plus 5 second, but you do not mix it up. Don't say this is m minus 5 and m plus 9. Since the middle term was negative, the larger number has to go with a negative. Number 18 looks like this. 3a squared minus 21a plus 30. Again, just like I looked with the other ones, I looked to see if there is a common factor. And in this case, there actually is. 3 goes into all of the 3 terms. So I'll put the 3 on the outside, and inside my parentheses, I'll get an a squared minus 7a plus 10. That's by dividing each term by 3. Now I look at the trinomial that's inside this parentheses, and I try and factor that. Again, not always is it going to be factorable. We just try. The a squared we break up into a and a. And again, I look at my sign. So the sign is positive, means both sides are going to be the same. The middle being negative means both sides have to be negative. And I need 2 numbers that multiply to 10, but when I add them, they give me 7. I think everybody realizes it's 2 and 5. And don't forget that 3 that was out there from before. So this becomes factored as 3, a minus 2, and a minus 5. Again, you could always check your answers by multiplying using FOIL your 2 binomials and then multiplying by the 3 and see if you get back to what you originally were given. Okay. Any questions about any of these? Okay, let's go on to the next. Next example that I gave you was number 20. And it says factor 4x squared minus 9. I'm sorry, not minus 4, minus 49. Sorry. And again, I look for a common factor, but there isn't one. Now, this is a binomial, so the only way I can factor it is if what I have is what's called the difference of squared. Is the first term a perfect square? Yes, it's 2x and 2x. Is the second term a perfect square? Yes, 49 is 7 and 7. And is there a minus in between? You have to have all 3 of these things in order for it to be factorable. If this, for example, would have been a plus, I couldn't have done anything further. I would have just have to leave it alone. But this is the difference of squares. So what I do is I take the square root of the first term, put it in the first in each of the parentheses. I do the square root of the second term, which is the 7 and the 7, and put it as the last term. And in one parenthesis, I put a plus, and one parenthesis, I put a minus. These are what we call conjugate binomials. When we multiply conjugate binomials, we don't get a trinomial, we get a binomial, which is the difference of squares. So therefore, we have now the difference of squares factored as 2x plus 7 and 2x minus 7. 21, we have 9x squared minus 121 y squared. Again, it's a binomial. There again is no common factor, but we have the first term is a perfect square, and the second term is a perfect square. So I'm going to put 3x and 3x in each parentheses for my first term, and one a plus and one a minus. And 121 is 11, so it's going to be 11y and 11y. Again, these are conjugate binomials because my original expression was the difference of squares. Number 22 is again a binomial. It's just w squared minus z squared. Again, it's no common factor, but these are the difference of squares. So all I have to do is w plus z and w minus z. Again, some of them are really easy. Some of them are a bit more difficult. Any questions on any of these? Okay, so now we're going to go on to question number 26. It says factor completely 4s to the squared. Oh, I'm sorry, 4s to the fourth. Read it carefully. Minus 12s to the third. Minus 8s squared. And again, as I've been doing with all of these, whenever I factor, I look for a common factor first. So looking for the common factor, first of all, 4, 12, and 8, there's a common factor of 4. And S4, S3, and S2, they all have S's, and the lowest exponent I see is 2. So 4s squared is my common factor. Okay, now I factor out, I divide each term by the 4s squared. So the 4 into the 4 canceled, s squared into s fourth. Remember, when you're factoring or dividing, you subtract exponents, and 4 minus 2 is 2. So this gives me s squared as my first term. 4 into negative 12 is negative 3. S squared into s third, again, I'm left with just s to the 1, which is just plain s. And finally, 4 into negative 8 is negative 2. And the s squared into the s squared just cancels out. So I'm left with, inside my parentheses, with s squared minus 3s minus 2. Now this is a trinomial, so I really want to try and see if I could factor this further. So let's see if I can. The s squared I would break up into s and s. Since my last term is negative, it means one sign is going to be plus and one sign is going to be minus. And I need numbers that multiply to 2. Well, that could be only 1 and 2. But when I subtract them, I get 3. Hey, when I subtract 1 and 2, I get 1. I'm not adding them, I'm subtracting them. As a matter of fact, I can't go any further. This is not factorable. So therefore, I tried, but as I said, not every trinomial or not every expression is factorable. My final answer is 4s squared times s squared minus 3s minus 2. So if it doesn't follow through, you cannot factor it. You can't say, oh, it should have factored. It didn't, so we can't factor it. Now 27 looks like this. 9x squared minus 81. Again, my first step is to find a common factor. And in this case, there is a common factor. There's a common factor of 9. I must always look to see if I can take out a common factor. So 9 into 9x squared gives me x squared. 9 into negative 81 is negative 9. And now I recognize that x squared minus 9 is the difference of squared. So I can factor that further. x and x, plus and minus, 3 and 3. So this was factorable, but don't start right away and say, oh, this is a difference of squares. Let's just break it up into 2 parentheses. Look for a common factor first. It's called factoring completely, and that's the kind of factoring you want to do first. Okay, I guess I now have to erase. Any questions about these before I start erasing? Okay, let's do the next one, which is 28. $28 looks like this: 12x to the third y minus 75 x y to the third. And again, the first thing I want to do is to break this up by finding a common factor if there is one. So there's a 12 and a 75. And does any number go into both 12 and 75? And yes, the answer is 3. 3 is a factor of 12, and it's also a factor of 75. Then we look at the letters, the variables, x to the third and x. There's a common factor of x. Y and y to the third is a common factor of y. So my greatest common factor is 3xy. Now I divide this into each term. 3 into 12 gives me 4. X into x to the third gives me x squared. Y into y just cancels out. Now I do the same thing with the second term. 3 into negative 75 is negative 25. X into x cancels out. Y into y third gives me y squared. And what I see now is this binomial inside the parentheses is the difference of 2 squares. So I can factor that further. I'll leave this 3xy alone. And this, I break the, there's no more common factor, but this is 2x times 2x. Again, since this is minus, this becomes a plus and a minus. And 25y squared is 5y and 5y. Again, here are conjugate binomials because this was a difference of squares. And this would be the result of factoring number 28. Now, looking at number 29, we have 81 s fourth minus 225 t squared. Now, is there a common factor in 81 and 225? And I think 9 goes into both of them. Let me check on my calculator. 225 divided by 9 is 25, yes. So the first thing I am going to do is take out my common factor of 9. Don't assume there's no common factor. Make sure you try. 9 into 81 is 9 s fourth. And 9 into negative 225 is minus 25 t squared. And if you notice, what's inside the parentheses is, again, the difference of squared. 9s to the fourth is 3s squared times 3s squared. As soon as your exponent is an even exponent, it's a perfect square, because s squared times s squared will give you s to the fourth. So I leave this 9 on the outside. Here are my 2 binomials, 3s squared and 3s squared, plus and minus, because this is minus, And 5t squared is 5t and 5t. We can't factor any further because everything is, there are no more. This is not the difference of squares, nothing more to be done. So these are the examples that I had given you for homework on practice sheet 4. You'll see there are more homeworks. That's what's going to be for tonight. Don't forget also to look on Delta Math if there is any homework on Delta Math. There is going to be homework. All right. We will be today completing chapter 4. Now, actually, chapters 1 through 4 are the material that is usually on the midterm. I haven't heard anything about the midterm, but if it's like other terms, then the first 4 chapters are what's on the midterm. So here's what I'm going to do. We first need a test or quiz on the 2 chapters 3 and 4. That which is going to be the systems of equations and the polynomials. Now, next, I'll assign it next Thursday because I'm going to do some review on Tuesday. It will be on Delta Math as well. It'll be a test like the other one on Delta Math. By the way, if you have not completed all the assignments on Delta Math, I went and I changed the due dates on the assignments. The assignments, there is a little bit of a penalty for doing it late, but if you haven't completed those assignments, then go back. You have until, I think I even extended it as far as October 30th. I think that's the date I chose. So make sure you have those assignments done. If you want to redo the test on Delta Math, make sure get in touch with me so that I can reset it. Reset it, and I can then, and then you could have a second chance at doing that test. Again, you must do the assignments to get the credit for the homework. But the tests are what you're going to get are going to decide whether you get an A, a B, or a C, etc. In addition, after you've completed that test on Delta Math, probably the next time I will assign a test on Blackboard, which is going to be similar to your midterm. It's going to be on all 4 chapters, and it's going to be multiple choice. It'll be a test on those first 4 chapters, number 1, and also it'll be practice for the midterm. I'll talk about that again next week. But remember to look out for the test on Delta Math starting on the 8th. And if you after that, I will tell you exactly when to look out for the test on Blackboard. When I assign the test on Delta Math, I'll give you a couple of days to complete it. But please, this time I'm not going to extend the dates. I've been doing that because I know people have been having problems. But from now on, we have to continue what we've been doing. With that said, unless somebody has a question, anybody have any questions or anything about that's going on? Okay, then I'm going to continue with the next topic, which is a continuation of, which is a continuation of factoring of trinomials with a little of a twist. Let's look at this example. Suppose I gave you this example. 3x squared, no, that's not what I want. Minus 10x minus 8. Suppose I give you this trinomial and I ask you to factor it. Now, what's different about this one? Well, there's a number in front of the x squared. There is a leading coefficient of 3. And it's not a common factor. In other words, I can't factor out this 3. So the question is, what do I do when I have this sort of situation? Now, there are a number of ways of dealing with it, but I'm going to use something that sometimes I know some of the students call it the AC method, and sometimes it's called the grouping method. And I'm going to demonstrate it. I think most of you have seen it, but I will go through it completely. In a standard trinomial, the first term, the coefficient of the first term of the x squared is called the a. The coefficient of the x term is called the b. And the number that stands alone is called the c. That's why this is called the AC method, because it involves using the 3, the leading coefficient, and the negative 8, the last term. What do we do in this case? We multiply those two numbers together. We multiply the 3 and the negative 8, which gives me negative 24. And instead of using the negative 8 like we did before, we're going to use a negative 24. First of all, we're going to want to find out two numbers multiply to a negative 24. Well, since they're negative, one will have to be positive and one will have to be negative, like we did before. Not only that, they have to multiply to 24 and subtract, because this is minus, to 10. Now, what numbers multiply to 24, but when we subtract them, give us 10? Well, if I multiply to, it could be 24 and 1. It could be 12 and 2. It could be 8 and 3. These are all the products of 24. Or it could be 6 and 4. Now, all of these, which subtract, this is a minus, so it has to subtract to 10, and it has to be the 12 and the 2. And not only that, it has to be, since this is the 10, this is a negative 10x, the larger number has to be the negative, and the smaller number has to be the positive. So what I do now, so this is just like what we did before when we were trying to figure out what numbers to use. But what I do now is, instead of right away writing my two parentheses, I take that middle number, that negative 10x, and rewrite it as negative 12x plus 2x. In other words, I use this system, this AC system, to figure out how to break up the middle term into two terms. So that, and obviously negative 12x plus 2x is negative 10x, but I want them not together as a single term, but I want them separate. And I leave this the 3x squared, and this I leave the negative 8. Now, the object of doing this is because now once I have 4 terms, I can use grouping to factor. I group my first two. In my first two, 3x squared minus 12x, my common factor is 3x. 3x into 3x squared gives me x. 3x into negative 12x is negative 4. The x's cancel out. Then I go to my second group, 2x minus 8. There's a common factor of 2. And since it starts with a plus, the leading coefficient of that second group is positive. This is a +2. Whatever sign you have here in the middle, that's what goes with this second group. So +2 into 2x is x, 2 into -8 is -4. You know you're on the right track because the two binomials that you see are identical. To finish this factoring, you take the common binomial factor, which is the x minus 4. And that in your second parentheses, your second binomial are the numbers that you find outside the parentheses, which is the 3x and the +2. And if you were to multiply these two together, you would see that this is what you were getting. In other words, this whole process is to get the middle term back separated, because when you really multiply two binomials, you are doing 4 multiplications. So we have to separate that into what the original 2 terms that it was. Let's do another one. Okay. Here's my eraser. Here's the next example. I'm going to do one more completely with you, and then I'm going to give you one to try. Okay, we have 9x squared plus 15x plus 4. And again, I see a trinomial that I want to factor. And I look at the terms, and there's no common factor, but there's a leading coefficient of 9. There's a number in front of that 9. Okay, so I know I have to use the AC method. I have to take the 9 and multiply it by the 4, which gives me a positive 36. And I'm going to be looking for numbers that multiply to positive 36. Now, since it's positive, either both numbers are positive or both numbers are negative. When I look at the middle and I see that that's also positive, it must mean that both signs are going to be positive. So now we're looking for numbers that multiply to 36, but when we add them, they're going to give me 15. So let's look through what we have when we multiply to 36. It could be 1 times 36. It could be 2 times 18. It could be 3 times 12. It could be 4 times 9. I think that's the combination. Of these group, the only ones that add to 15 are the 3 and the 12. In other words, I have to take this 15x and rewrite it as positive 3x plus 12x. And bring down the 9x squared and the 4. Remember, I don't use the 36 anymore. I go back to the 4. I'm using the 36 just to figure out the numbers. And now I have my 4 terms, so I can group. In my first group, 9x squared and 3x has a common factor of 3x. So 3x into 9x squared is 3x. 3x into 3x. Everything cancels, so it's plus 1. Don't forget, if everything cancels out, you're left with a 1. Okay, now we do the second group. 12x plus 4 has a common factor of 4. And it's positive because this term is positive. So plus 4 times 4 into 12x is 3x. 4 into 4 is 1. again, we are on the right track because these two binomials are identical. So therefore, my answer becomes 3x plus 1 in one parentheses, and my second parentheses is 3x plus 4. So when you have a leading coefficient, the factoring is more difficult, but as long as you follow the pattern, you will get it done. Okay, I'm going to give you one to try now on your own. Does anybody have any questions they want to ask before? Okay, so let's go. See if you could do this one. Eight x squared minus 2x minus 15. While you are doing this, I'm going to take attendance. Okay, we have this 8x squared minus 2x minus 15. There is a number in front of the x squared, but it's not a common factor. So again, we're going to have to use that AC method, which means we're going to have to take the A and the C and multiply them. 8 times negative 15 is negative 120. Okay. First of all, since it's negative, one number is going to be positive and one number is going to be negative. And we need numbers that multiply to 120, but since this is minus, they have to subtract to 2. And the numbers I can think of right away are 10 and 12. Because 10 times 12 is 120, but when you subtract them, you're going to get the 2. And it's going to be the 12 that's going to be the negative, because a larger number is going to have to be negative because this middle term is negative. So now that I've figured out these two numbers, I'm going to rewrite the negative 10x as plus the negative 2x as plus 10x and minus 12x. Notice if I would have combined them, I would have gotten this negative 2x. I do this because I want to end up with a total of 4 terms. So this will stay the 8x squared, and this will stay the minus 15. And now I have 4 terms, so I can do grouping. My first group, 8x squared plus 10x, has a common factor. Well, 8 and 10 has a common factor of 2. X squared and x is x. So it'll be 2x times 4x plus 5. In my second group, I have negative 12x and negative 15. Obviously, 12 and 15 has a common factor of 3. And since my first term of this group is negative, I'm going to have a negative 3. I always determine what sign to put here by the sign in this middle. So negative 3 into negative 12x gives me positive 4x. And negative 3 into negative 15 is positive 5. Again, I see I'm looking at the right thing because I have 4x plus 5 in each of those binomials. So I put the 4x plus 5, the common binomial factor, first. And second, I put what's on the outside, the 2x and the minus 3. And that's how you should have factored this example. All right, let's try another example. What if I had given you this example? Four x squared minus 11xy minus 3y squared. Let's say this was our trinomial. Now, first of all, we are starting with a leading coefficient of 4. And that 4 is not a common factor. But on top of that, we don't have just one variable, we have two variables. Now, if you recall what I said, to make it look simpler and to make it a little bit easier to do, rewrite the trinomial with only one variable. In other words, leave all the x's, but leave out all the y's. So you get a trinomial that looks like 4x squared minus 11x minus 3, none of the y's. What we'll do is, after we factor this, we'll stick the y's back in by just putting them on in the end, and that'll give us the correct answer. Now this is very similar to what we've been doing. We're going to use the AC method. 4 times negative 3 will give me negative 12. So I'll look for two numbers that will multiply. Well, first of all, since this is negative, one will have to be positive and one will have to be negative. And they're going to have to multiply to 12, but subtract to this number, which is 11. Well, obviously that has to be the number 12 and 1. That's the only thing that multiplies to 12, but when you subtract them, give you 11. And since this is a negative 11, it's the 12 that's going to be the negative and the 1 that's going to be the positive. So when I rewrite this thing, the negative 11x, I'll write it as a plus 1x and a minus 12x. Again, I'll leave the 4x squared alone and the negative 3 alone. And here is my 4 terms, so I can group it. In the first group of 4x squared and 1x, my common factor is x. And I get 4x plus 1 inside my parentheses. In my second group, between the 12 and the 3 is a common factor of 3. But since that middle term here, the negative 12x is a negative, I have to keep as part of that negative 3. I always have to decide what sign to use, and I just look at this sign, and that's the sign I use. So I'm going to divide each of these terms by negative 3. Negative 3 into negative 12 is positive 4x. Negative 3 into negative 3 is plus 1. So that this ends up being 4x plus 1 in one parentheses and x minus 3 in your other parentheses, because those are what's on the outside. Now that's the answer to this thing. But we wanted to factor actually this. So I rewrite the two parentheses, 4x plus 1 and x minus 3. Notice I'm leaving more space because at the end, right next to the last number, I put a y in both parentheses. Now actually, we usually don't write 4x plus 1y. We usually write it 4x plus y and x minus 3y. In other words, I do this simpler looking expression, and it gives me, by just sticking the y's in at the end, it gives me the correct answer. Again, if you want to check it, you just do FOIL on this, and you will see that you get the right answer. Okay? Any question about that? Okay, so let's look at another example. Let's say I gave you this one. 40r to the third minus 120r squared plus 90r. See if you can factor it. I'll give you a hint. Look for your common factor first. Look to see if you have a common factor. I'm going to turn off the recording for the few minutes. All right, let's see if we can do this together now. Like on all examples, when I'm looking to factor something, my first step is to find a common factor if it exists. And I look at the 40, the 120, and the 90, and I see 10 goes into all of those terms. And on top of it, each of the terms has an r in it. So the r is a common factor. It's with an exponent of 1 because that's my lowest exponent that I see. I'm now going to divide out the 10r from each term. So 10 into 40 gives me 4. R into r to the third is r squared. Then I do 10 into negative 20 is negative 12. R into r squared is r. And finally, 10 into 90 is 9. And r into r cancels out. So I'm left with a trinomial of 4r squared minus 12r plus 9 inside my parentheses, and a common factor, the greatest common factor of 10r. I'm going to now try and factor this trinomial. And since it again starts with a leading coefficient, I'm going to have to use the AC method. I'm going to multiply the 4 times the 9. That'll give me, my AC will be positive 36. Now, since it's positive, I have to decide what signs I should use. They both have to be the same because we get a positive answer when we multiply. Two. Yes, this is still part of factoring trinomials. We're still working on trinomials. Since this is a positive 36, we're either going to have 2 pluses or 2 minuses. I look at that middle term and it's negative. It must be that they're both negative. So I'm looking for 2 numbers that multiply to 36. And when I add them, because it's positive, it'll give me 12. And I think everybody will realize it's 6 and 6. So I'm rewriting this negative 12r as a negative 6r and negative 6r and splitting it up. I'm leaving the 4r squared. I'm leaving the plus 9. And I'm going to group. 4r squared minus 6r have a common factor of 2r. 2 into 4 is 2. R into r squared is r. 2 into negative 6 is negative 3. R into r cancels out. My second group starts with a negative, so my common factor is going to be negative. Even if there's no common factor other than 1, I put that down. I have to put down some common factor. Well, between 6 and 9, the common factor is 3. So this is going to be a -3 on the outside. -3 into -6r is positive 2r. -3 into positive 9 is -3. So therefore, my common binomial factor is 2r minus 3. And what goes in the second parentheses is another 2r minus 3. And I could leave it 2r minus 3 times 2r minus 3, or I could rewrite that as 2r minus 3 with a square outside the parentheses. The binomial is squared. Don't forget the 10r from before. Here would be my answer. Again, if you wrote it 10r times 2r minus 3 and 2r minus 3, that would be correct. But if you're going to have a multiple choice question, it's more likely to be given this as the answer than that as the answer. So remember, if you have a binomial multiplied by itself, you could write it as a binomial with a square on the outside. I think that pretty much takes care of all the type of factoring that we could do. We've learned how to factor binomials, trinomials, and four-termed expressions. And for homework, aside from your homework that you're going to find on Delta Math, on sheet 4, I'm going to want you to do 19, 24, 25, and 30 through 38. And now I want to do the second part of what I discussed before. I said we were going to finish this chapter, and the last topic in this chapter is something called quadratic equations. Here is an example of an equation that's called a quadratic equation. This is one example. 2x squared equal 5x plus 3. Here's another example. 5x squared equals 75. Here's another example. 4x squared minus 3x plus 2 equals 0. These are all examples of something that we call quadratic equations. And what they all have in common that we didn't have in our first type of equations that we learned to solve is the fact that they have an x squared. They have a degree 2. They have a exponent of 2 on the variable, sometimes also called second degree equations. The type of equations that we started out the term with were called linear or first degree because there were no exponents. And we reviewed how to solve them. We are now going to go to the next stage, which is how do we solve an equation that has a variable that's at an exponent of 2. And even what if it had an exponent of 3 or 4? How do we solve those? But let's start with this. Now I'm going to, I should rewrite these. I'm going to start with a simpler example than any of these. I'm going to have enough room to leave this on. Let me move this a little bit. And I'm going to come back to these a little bit later because they're a little bit more complex. I want to start out with one that really is simpler. Let's say I had this equation, x squared minus 2x minus 24 equals 0. Again, I know it's a quadratic equation because it has an x squared in it. Don't tell me it's a quadratic equation because it equals 0. That is not what makes it a quadratic equation. What makes it a quadratic equation is the fact that it has, one of the variables has at least an exponent of 2. Now, what we do with this is even if it isn't equal to 0, we make sure to make our example equal to 0. This is different than the way we solved regular linear equations, because in linear equations, we try to get the x's on one side and the numbers on the other side. When we're dealing with quadratic equations, we try to get everything to one side equaling 0. And we try to make sure that if it's a trinomial, that it's in what we call descending order, in the standard form of a trinomial. Well, this one is x squared minus 2x minus 24 equals 0. What we then do is we factor. We break this up into its two binomials, if it can be factored. This is not the only way to solve quadratic equations. We're going to see other methods later in the term, but this is the way we deal with the simplest examples. Now, this is an old-fashioned leading coefficient of 1. I break the x squared into x and x. And I look at my last term, it's negative, meaning one parentheses is going to have a plus, one is going to have a minus, because the two numbers have to be different signs to give you a negative answer. And what multiplies to 24, but when we subtract it gives us 2, and that must be 6 and 4. And since the middle term is negative, the larger number, the 6 is going to be the negative, and the 4 is going to be the positive. We have factored, but we haven't finished solving this equation. I will know that this has to go further because number 1, it will say solve the equation. Number 2, there'll be an equal sign in it. So you don't stop when you finish factoring. What you do is, well, I'll give you a reason before it. Think about this. This parentheses, x is some number. So x plus 4 is some number, let's call it a. And x minus 6 is some other number, call it b. So we have these two numbers, a and b, that are being multiplied. And the answer that you're getting is equal to 0. Now, 0 has a very interesting characteristic. Anytime you multiply two numbers and your answer turns out to be 0, it must mean that either the a equals 0 or the b equals 0. Otherwise, you won't get 0 as an answer when you multiply. What does that mean? That means in terms of our specific example, if x plus 4 times x minus 6 equals 0, either the x plus 4 equals 0 or the x minus 6 equals 0. Now, if the x plus 4 equals 0, I can figure out what x is by bringing 4 to the other side, and I'll get x equal negative 4. If the x minus 6 is 0, I can solve that by bringing the 6 to the other side, and that'll give me x equals 6. And both of these numbers are answers to my quadratic equation. Both of them, when you substitute them back into the original equation, will give you a true statement. When you have a quadratic equation, what you're looking for are two separate answers, because there are two numbers that can be multiplied. Either of the numbers could have been the 0. So my answer in this case is negative 4 and 6. Sometimes we put it inside these braces. So that gives us the basic start as to solve a quadratic equation if it's factorable. We'll worry about them when they're not factorable, as I said, later in the term. Let's go again through the steps. We make sure that we know it's a quadratic equation because we see an exponent of 2. We make sure it's equal to 0. If it's not equal to 0, we're going to have to bring everything to one side. Then we factor completely and set each of the factors equal to 0 separately. And they each give us simple equations that we solve to get our 2 answers. So let's see how that applies to the first one over here. Number 1. To 2x squared equals 5x plus 3. Again, I see it's a quadratic equation. It has an equal sign and the exponent of 2, but it's not equal to 0. And the first thing I have to do is make sure that my quadratic equation equals 0. Okay, so therefore, I'm going to have to move some things. Now, here's how I decide where to move. I look at the x squared term. I always would like my x squared term to be positive. So if where it's standing is already positive, leave it there. If the x squared term is negative, then move the x squared term. Well, this is a 2x squared and it's positive, so I want to leave the 2x squared over here. So I'm going to subtract 5x from both sides. And I'm going to subtract 3 from both sides. So that I end up with everything on the left side of the equation. This will give me 2x squared minus 5x minus 3 equals 0. Okay, now I have a trinomial and it's equal to 0. It's the standard format to solve a quadratic equation. I have to factor. There's no common factor here, so therefore I'm going to have to use the AC method. The A times the C is -6, because 2 times -3 is -6, which means one is going to be positive and one is going to be negative. And I need them to multiply two numbers and multiply to 6, but when I subtract them, they're going to give me 5. Now remember, they're going to subtract to 5. And the only possibilities are 1 and 6 or 2 and 3. And I picked the 1 and 6 because when I subtract 1 and 6, I get 5. Don't make the mistake of picking the 2 and 3 because those add to 5. They don't subtract to 5. In other words, I'm going to rewrite this -5x as a -6x and a +1x. I'll keep the 2x squared and I'll keep the 3. Okay, I'm going to have to erase this so that I can continue this problem on this side. So now we have the 2x squared the -6x, the +1x, and the -3, that equals 0. And we're going to split it because it's 4 terms, and we're going to use grouping. In the first group, we have a common factor of 2x. 2x into 2x squared gives me x. 2x into -6x gives me -3. In my second group, there is no common factor, but everything has a common factor of 1. So I'm just going to put a +1 in the front and an x -3 in the parentheses. So that this ends up being x -3 in one parentheses, and the other parentheses is the 2x plus 1. When you're using this grouping method, you must put a number in front of the second group. If there's nothing in common, then you put a 1. Again, it's a plus 1 because the middle term was plus. If this would have been a minus, it would have been a minus 1. Okay. And now we do what we did before. We take each of these parentheses and separately set them equal to 0 to get our two answers. Either the first parentheses can equal 0 or the second. In the first parentheses, if I have x minus 3 equals 0, I can add 3 to both sides, and that'll give me x equals 3. One of the answers to this problem is x equals 3. In the other parentheses, I have 2x plus 1 equals 0, so I'm going to subtract 1 from both sides. This will give me 2x equaling negative 1. And now I have to divide by 2 because I want x. So I get my other answer as negative a half. My two answers are 3 and negative 1/2. So again, this was a harder example simply because the factoring was harder, but the concept is the same. Get it equal to 0, and then factor and separate each of the factors, each of the parentheses, and make them equal to 0. Is there any question about this one? Okay, I'm going to do the next one, and then I'm going to give you one to try also. The 5x squared equals 75. It looks like it's missing things, but actually it is a quadratic equation because it has an x squared, which means I have to get it equal to 0. And again, the 5x squared, the x squared term is positive, so I'm going to bring this 75 to the other side. So this gives me 5x squared minus 75 equaling to 0. And I want to factor this. And the first thing I see is that I have a common factor of 5. So I put the 5 on the outside, and I get x squared, and 5 into 70. I made a mistake. This should have been a 3. I'm sorry. It should have been a 3. Otherwise, I can't work it out. Sorry about that. Let's change all these 5s to 3s. Okay. In 3x squared minus 75, the common factor is 3. So I get 3 and x squared, and 3 into 75 is 25. And this binomial inside is a difference of squares, so I can factor that further. X plus 5 and x minus 5, because when we have the difference of squares, we get the two conjugate binomials. And again, we do what we did before. We take each of the factors. Now, there actually are 3 factors here. The 3, the x plus 5, and the x minus 5. Now, I really should set each one of these 3 factors equal to 0. But if I set 3 equal to 0, that's obviously a big mistake. 3 is not equal to 0. 3 can only equal 3. If there is no x, if there's no variable, if it would have been 3x, yes, it could be equal to 0. But 3 alone is only equal to 3 and never equals 0. So we just forget about that. But the x, we take the other factors, x plus 5 can equal 0, and x minus 5 can equal 0. They both have variables, so they could be equal to 0. In this case, I get x equal to -5. And in this case, when I add 5 to both sides, I get x equal to +5. So my answer is -5 or +5. Sometimes actually written like this, ±5. If you ever see a symbol that has a plus or a minus, it's just a way of writing things shorter by saying it's a +5 and a -5. It's both answers, so just write a plus or -5. So that would be the answer to this question. How to solve 3x squared equals 75. Okay, we have a few minutes, so let's see if you can do this last example. 4x squared minus 3x plus 2 equals 0. See if you can solve that example. Give you a couple of minutes. Erase this because it makes it look too messy. And look at this last question, 4x squared minus 3x plus 2 equals 0. It's definitely a quadratic equation that has an x squared, and it's in the right setup. It has the x squared, the x, and the number equals 0. It already equals 0. And what we want to do is factor it and set each of the factors equal to 0. And again, we have that same problem that we have a leading coefficient, and it's not a common factor. So we're going to again use the AC method. We're going to take the 4 and multiply it by the 2, and we're going to get a +8. Now, since it's positive, it means both signs are going to be the same. And since the middle term is negative, it means both the numbers are going to have to be negative. And we're looking for two numbers that multiply to 8, but when we add them, will give us 3. And what happened here, I hope you all realized, you can't factor it. Not every trinomial is factorable. In other words, the method that I taught you about solving quadratic equations is not totally infallible. There are times that it doesn't work. That's why we're going to have to learn a different method. We're not going to learn it in this chapter. We're going to go a couple of chapters, and then we're going to come back to quadratic equations and learn what happens when the factoring doesn't work. What if you can't factor? Or what if you could factor, but it's such a difficult factor you can't figure it out? There are other options. So that's something that we're going to be dealing with in the future. So don't forget to try on your homework sheet for examples 19, 24, 25, 30 through 38. And again, look for an assignment on Delta Math. Make sure you do your assignments. Again, if you're missing any assignments, make sure that you do them now because I've opened them up. I've changed the due dates. Also, if you have anything that you'd like to discuss with me, either make an appointment to meet me on Zoom or email me. I'm always available. Remember, we're coming up. We've already finished 5 weeks of class. By 7 weeks is midterm time, so we're halfway there almost. So make sure you're keeping up with the material. I want to see everybody passing this course. Any questions? Can you stay on for a few minutes after everybody leaves so I can talk to you? Oh, great. All right. I think right now I'm going to end the class. Again, anybody have a question, you can definitely let me know what your question is. Have a nice weekend. Everybody stay well, and I will meet with you again on Tuesday. Remember that we're going to be we finished chapter 4 and we're going to be having this test. There are 2 tests in line. The first on Delta Math, and then a week later a test on all 4 chapters as a preview for the midterm. Okay, have a good day.